Okay, so you are welcome back to this episode. We have to also see what operations you're going to perform on these fractions. In our previous episodes, we quickly dealt with how we can translate objects into fractions. So how we have a part of an object, like understanding from the basics what fractions truly are. And then you remember we said that every fraction has got two parts. It has the numerator part and it has the denominator part. Today we want to perform operations on these fractions, and we're going to begin with multiplication. Now usually you're going to have to see multiplication as this. So this is multiplication, multiply. Okay, this is one way you're going to see it. You also have to see multiplication as this. This can also be multiplication, and then sometimes you're going to have to see something like this. A parenthesis is also a form of multiplication. Yes, and then if you have off, sometimes you have off can also denote multiplication. Any of these, for instance, if I have a of b, which is a fraction, times c of d, so this is our multiplication. You can see that this same can be written as a on b and then c on d. This is also multiplication. You can have something like a on b in one parenthesis, and then this also in another parenthesis, c on d. This is also multiplication. And then you can have a on b of c on d. This is also multiplication. Either of these they are multiplications, and you have to, the concept of multiplying fractions do not change. To multiply fractions, you have to take note of the numerator of the fraction and then the denominator of the fraction, right? So it's a very simple concept. You multiply the numerator of one fraction by the numerator of the other fraction. So if I have a over b and multiplying c over d, all I have to do is to multiply the numerators, multiply them, and then multiply also the denominator. So this will end up becoming a times c all divided by b times d. Yes, so it is a very simple concept. Let's look at some examples in here. Our first example is going to be 2 over 3 times 4 over 5. So to be able to solve this, you should be able to understand which part of these fractions are numerator and which part also form the denominator. We can see that I'm going to indicate this. These are all the purple are numerators, and then you can also see the blue ones as denominators. You got that? So you multiply that, pretty simple. 2 times 4, and then all divided by 3 times 5. 2 times 4 is 8, 3 times 5 is 15. So this becomes our answer. Very simple. Let's practice this. 7 on 6 times 1 on 4. Okay, so this, our numerator is 7 on the first fraction here. This is our numerator, 7 here, and then our numerator here is 1. So we just have to multiply that. 7 times 1 all divided by 6 times 4, and that should give you 7 over 24. So give this one a try. 7 over 24. Yeah, give this one a try. If I have 8 over 15 over 6 on 5, give it a try. Let's see. 5 over 3 times 9 over 10, and then 40 over 9 times 2 over 3. Yeah, I think this is okay. So if, let's see, I expect that this, you're gonna have 8 times 6 all on 15 times 5, and you know 8 on 6, 8 times 6 is 48, and then 15 times 5 is 75, right? This is pretty simple. 5 times 9, 5 times 9, 3 times 10. 5 times 9 is 45, 3 times 10 is 30, and then here 40 times 2 over 9 times 3. This is going to give you 80 over 27. So it is a very pretty simple steps. I mean, just understand that you multiply the numerators, you multiply the denominators, and this is true. It doesn't matter the number of fractions you are multiplying, as long as they are multiplying, you are good to go. So 2 over 3 times 4 over 5 times 1 over 2 times 3 over 7. Now they are multiplying, so all you have to do is to multiply all the numerators and divide by 3 times 5 times 2 times 7. So 2 times 4 is 8. Let me show you that. 2 times 4 is 8. 8 times 1 is 8. 8 times 3 is 24. So this will give you 24. 3 times 5 is 15. 15 times 2 is 30. 30 times 7 is 210. Yes, so this is going to be our final answer with regards to this problem. So multiply the numerators, multiply the denominators, and we are good to go.